Today I am going to start part 2 locus. In previous my video it was part 1 definition and introduction of locus. I hope you had understand everything and I would like to recall once again what is locus. Locus is the path of a moving point. Locus is the path of a moving point under certain geometrical condition. Without geometrical condition, at random anywhere we cannot draw the locus. Just like a small example again I am giving. Two fixed point A, B is given. Now the shortest distance of AB. Shortest distance of AB. This shortest distance of AB is condition of geometry. So joining AB straight, it is the locus. It is a locus. And if I join AB anyway like this, that is not locus. Under certain condition, geometrical condition, shortest distance of AB, then this one is locus of moving point P. In this way, I explained in my previous video everything, and today going to start part 2. I have written theorem first. The locus of a point P which is equidistant from two given point A and B is the perpendicular bisector of the line joining AB. That is a theorem. That means what is given? Two fixed point A and B given. Two fixed point A, B given. P is a moving point. P is a moving point such that in this path each and every point is equidistant from A and B. It is given. P is moving point such that AP is equal PB. Now to prove P lies on the perpendicular bisector. P lies on the perpendicular bisector of the line segment AB. Now construction, join A and B because only fixed 2 points are given. So join AB, and for construction AP and BP also. It is a proof. Understood? The locus of a point which is equidistant from two fixed points is the perpendicular bisector of the line segment joining the two fixed point. That is your theorem. Now proof. In triangle PAM and triangle PAM and PBM, they are given. These two are equal because at equidistant, and M point also on the path of perpendicular. That's why this point also equidistant from AB. This one also equal. So in both triangle PAM and PBM, PA is equal PB. PA is equal PB. AM is equal BM and MP is common in both triangle. MP is equal MP because it is a common. This two also given there. It is given. M is midpoint. It is given. Now by SSS postulate of congruency, by SSS postulate of congruency, triangle PAM congruent to triangle PBM, to triangle PBM. Both triangles are congruent. Both triangles are congruent, and if both are congruent, implies PMA, angle PMA is equal angle PMB, angle PMB. Biciplicity. Biciplicity. This angle is equal to this angle. Now AMB is linear angle. AMP and BMP are linear pair angle. So sum of both is equal 180 degree. Angle PMA plus angle PMB is equal 180 degree. If this angle is equal to this one and sum of both 180, it means both are 90. Both are 90 degree. Implies angle PMA is equal angle PMB is equal 90 degree. Now your theorem proved. That means if it is 90 degree, that means PM is perpendicular bisector. Bisector according to given point. According to given point in this path, each and every points are equidistant from A and B. It is given. That means this point also lies on this line. So AM is equal MB also given. AP is equal BP given. Both are given, and this one is common. So by SSS postulate, both triangles are congruent, and if both are congruent, then this angle is equal to this angle. It is 90 degree. That's why it is perpendicular bisector. That was to prove. It is your theorem. Understood? Now converse of this theorem. I am going to start converse of this theorem. Now converse of theorem. Converse of theorem first. Any point on the perpendicular, any point you can take all this, any point at random P I have taken, any point. Theorem is converse just opposite of your theorem. Any point on the perpendicular bisector, that means perpendicular bisector is given. Perpendicular bisector is given of two fixed points joining them. Their perpendicular bisector is given, and you have to suppose any one point on this perpendicular bisector. There also we can suppose, there anywhere you can suppose the point, random any point. Then this point is equidistant from A and B. That we have to prove. Suppose taking this point, then this also equidistant from the point A and B. Any point on the perpendicular bisector on a line segment joining two fixed points is equidistant from the two fixed point. That means any point on the perpendicular bisector, then any point on the perpendicular bisector is equidistant from two fixed point A and B. That we have to prove. That means given, what is given? A and B, two fixed points given. MQ, it is perpendicular bisector. It is a perpendicular bisector. That means this also given. Both are equal. P is any point. P is any at random point is there. Here also you can take. Here also anywhere. Here can take. I have taken there P. P is any at random point on MQ. Now to prove AP is equal PB. From here suppose this line is equal to this line. Suppose here, then this line is equal to this line. That we have to prove. That means any point on the perpendicular bisector is equidistant from the given 2 points. That we have to prove. Okay. Now in triangle PAM, in triangle PAM and triangle PBM, perpendicular bisector, it means AM is equal AM is equal BM. AM is equal BM. And perpendicular, that means 90 degree is given. Angle PMA is equal angle QMB. QMB is equal 90 degree. Perpendicular. And MP, wherever point, suppose that distance, that perpendicular is common in both triangle. So MP is equal MP because it is common. It is common, implies triangle PAM congruent to triangle PBM by which property? By SAS. By SAS. By SAS. Postulate of congruency. Both triangles are congruent. And if both are congruent, implies AP is equal BP by CPCT C. By CPCT C. Congruent part of congruent triangle, congruency. By this postulate, your both sides are equal. That means converse also true. Here, theorem and converse both are proved. Now I am going to prove second number theorem. The locus of a point equidistant from two intersecting lines is the bisector of the angles between the lines. That means two intersecting point. I have taken AB and CD, two intersecting point. There two intersecting point, AB and CD. The locus of a point equidistant from two intersecting point. That means in this intersecting point there are two part. In this portion, interior portion, this one and this one, both are equal angle, vertically opposite angle, both are equal. So I have supposed in this side, you can take this side also, but anyway we can prove it, but I have taken this side. Now the locus of a point, locus of all those point which are equidistant from both the lines, then to find out the length, always I explained in the classroom, to find out any distance, suppose from this point we have to find this length, then we will draw perpendicular, and this distance is between both. Like this we can find out. The shortest distance of 2 points is the length between both. In the same way, the locus of each point which are equidistant from both the lines, then suppose this one my P point, then draw perpendicular from here, and this side perpendicular, both are equal I have taken. In the same way, suppose another point, these two are equal, these two are equal. In this way, another point, these two are, then your theorem is the locus of all the points, like this, all the points. In this side also same situation. All the points are bisector of this angle. Is it bisector of this angle? That means you have to prove this angle is equal to this angle. Understand? Same thing I have drawn here. First you understand what is given and what to prove, and construction what is. Your theorem once again, the locus of a point which is equidistant from two intersecting lines, is bisector of the angle between both. Is bisector of the angle between both. In both sides same theorem can be applicable. Now what is given? AB and CD. AB and CD, two intersecting lines are given, and intersecting point is O. A point P is taken equidistant from these two lines. equidistant, that means from this point I have drawn the perpendicular both side of both line AB and CD. It is perpendicular and this side also perpendicular, and given both lines are equal because P is equidistant from both the lines. That's why it is given. Now, to prove locus of P is bisector of the angle AOC. Locus means each and every point of like this. Each and every point is the locus of this type of point is bisector of this angle. Now that is to prove. Now construction, draw OP. Draw OP a line, that means join this OP a line, and PL perpendicular to first line and PM perpendicular to second line, which intersects to each other at point O. Now we will prove this angle is equal this angle and this angle is equal to this angle. Then if we prove one side, then another you can understand like that only. Now in triangle PLO and triangle PMO in these two triangles already given. PM is equal PL is given. OP is equal OP, common, and this one is equidistant. From both line, it is common. And one more thing, yes, it is a 90 degree. It is a 90 degree. This side 90 degree. Angle PLO is equal angle PMO is equal 90 degree. That means this angle is 90 degree equal. These two are equal, and this hypotenuse of this right angle triangle equal. It means by which postulate of congruency? It is RHS. RHS. Right angle S, one side, any one side. So this side is, and hypotenuse RHS. So by RHS postulate triangle PLO congruent to triangle PMO, and if both are congruent, then by CP/CTC angle POL is equal, this angle is equal POM, angle POM by CP/CT. By CP/CT, both angles are equal. It means it is a bisector. Locus of the point P, which is equidistant from both intersecting lines, is bisector of the angle. This angle. In the same way, this side, because this angle is equal to this one, vertically opposite angle, and this angle is equal to this one, vertically opposite angle, and as I have proved, both angles are same, so there also both are same. It is a bisector. In this way, we can prove it. Locus of P is bisector of angle AOC. That means it is bisector. Locus of the point P, which is equidistant from intersecting lines are bisector. In the same way, similarly, we can prove this also. Take any point P here and draw perpendicular like this. Draw perpendicular like this, perpendicular, and this side also perpendicular, and prove they are given both are equal, and then we can prove this angle is equal to this angle. In the same way there also. In this way, theorem is proved. And similarly, we can prove the converse also. Converse is given. Okay.